Hi, I'm Bob. Welcome back to our solutions to the exercises in the textbook Microeconomics Theory and Applications with Calculus, 5th edition by Professor Jeffrey Perloff. Thank you for joining me and solving the problems together. We are at Chapter 14, Oligopoly and Monopolistic Competition. We will continue to tackle the questions related to the Bertrand Oligopoly model today. Here's exercise 5.9. Two pizza parlors are located within a few feet of each other on the Avenue of the Americas in New York City. Both were selling a slice of pizza for $1. Then one of them lowered its price to 79 cents. The next morning, the other dropped its price to 75 cents. These price cuts led to long lines of customers. However, both firms claimed that they were losing money. The two proprietors had a meeting on the sidewalk. According to one, they reached an agreement and raised their prices back to $1. Can the identical goods Bertrand or cartel models be used to explain this series of events? Why or why not? Before the price cut, each firm was probably the Bertrand duopoly because they provide identical products. The Nash-Bertrand equilibrium price equals their marginal cost. If they lower the price, they have a loss. After the meeting, they form a cartel and they can set a monopoly price higher than the marginal cost, meaning that they can charge a price higher than $1 if they like. Let's solve exercise 5.10. Firms use marketing to differentiate their bottled water products. If the firms in this market engage in a Bertrand game, what is the effect of this differentiation on prices? What is the effect on welfare? The Nash-Bertrand equilibrium with identical products is that each firm charges a price equal to their marginal cost. Product differentiation enables firms to charge a price higher than the marginal cost. When firms produce identical products, the Nash-Bertrand equilibrium is the same as the price-taking competitive equilibrium. In other words, the social welfare is maximized and there's no deadweight loss. However, when products are differentiated, the Bertrand firms can charge a price higher than the marginal cost, which leads to deadweight loss. That is, the product differentiation reduces social welfare. The above analysis is based on the calculation of welfare as the sum of producer surplus and consumer surplus. If we include consumer choices and product variety in the measure of social welfare does not necessarily fall. Let's answer exercise 5.11. A Bertrand duopoly produces differentiated products. The firms face demand curves. Qi equals Q, P1, P2. Each firm has a marginal cost of M. What are the firm's best response functions? Describe how to determine the Nash-Bertrand equilibrium. We find the Nash-Bertrand equilibrium in two steps. In the first step, we find each firm's Bertrand best response function. Firm I's profit pi I equals price pi minus marginal cost M, and then times output Qi, where Qi is a function of Pi. The first-order condition for profit maximization is the partial derivative of profit with respect to its price equals 0. It leads to from I's Bertrand best response function. It is an equation containing Pi, I equals 1 and 2 in the duopoly model. The best response function tells us the optimal price a firm charges to maximize its profit for each possible price its rival sets. For a Bertrand duopoly model, I equals 1 and 2, so we have two best response functions. In the second step, the intersection of the two Bertrand best response curves determines the Nash-Bertrand equilibrium prices. Substituting the equilibrium prices into each firm's demand function, we obtain each firm's Bertrand quantity. Thank you for watching this video and subscribing to my YouTube channel. See you next time.